I mean, it's pretty. I mean, I think it's pretty well baked at this time. There's been lots of discussion about this. You know, in the new cloud world, applications route around failures, right? Just like the internet was designed for. I mean, if you come at things from the risk mitigation, pet's point of view, then of course, you're gonna try to wring all the risk out of the system. Problem is that you can never wring all the risk out of the system. There's no way to have 100% uptime. There's no way to reduce all risk. So then your next immediate question, this is why this came out of the hyperscale guys, they get to such a size that they risk hardware failures. It's happening all the time, constantly. Shit's breaking all the time at Google, just nonstop. So they had to say, okay, when it breaks, what are we going to do about it? And this is why you see people like Netflix taking something like the circuit breaker pattern. The circuit breaker pattern takes a distributed application and it says component A talks to component B. If component A is talking to component B, and at some point it starts seeing a high error rate or B goes away, it just backs off and stops trying to talk to B, so that you get less of that cascading failure kind of effect. And what's funny about that is that's not a new pattern. Actually, the first time I saw that was in the mid-'90s. Everybody who uses the internet uses a similar pattern indirectly through ISPs, all of which have something called BGP route flap dampening that occurs on the Cisco switches that they're running, or Juniper, whatever. And those that BGP route flap dampening does the same thing for routes on the internet. And so, when I think about IT, I think about it as never being. It's hard to come up with something completely new. I don't think of cloud as being new. It's a reconfiguration of stuff that we've done before, and we're trading off. We're moving from the land of risk mitigation into the land of it's going to fail. So how do we handle it, and what does that mean for the application layer? And I just don't think that that's really a debate. What are we debating?
We're debating APIs.
APIs are just a tool.
And they took it a step further to Chaos Monkey, which is one of my favorite pieces of software.
Yeah.
Assuming failure is such a constant that you actually replicate it and you bring down your own infrastructure constantly to make sure your system is redundant, that is what the modern cloud looks like. Not just the system will fail, but if we are not assuming failure and baking it in everywhere throughout the whole system, we're guaranteed to be down.
So I want to back up one step. So the panel is called Multi-Cloud Strategies, and I think if we look back at the history of cloud services, for a very long time, beginning in 2006 when Amazon was in private beta to arguably earlier this year or late last year, Amazon was the public cloud reference API. So everybody that wrote applications, I'm going to disagree with you, everybody that wrote applications, yes, it is still the reference, but there are challenges. So everybody that wrote applications said, I'm going to go talk to Amazon's API. And all the early cloud adopters hard-coded things to speak to this language. Sure, there were tools like Fog or libcloud or other abstraction engines that built a programming language agnostic interface to those cloud APIs, but by far and large, most people wrote to Amazon. Now you've got Google Cloud entering the mix. You've got Azure entering the mix from the public cloud perspective. You've got OpenStack, CloudStack. Now you've got Joyent shipping their product line entering the mix from the private cloud side. And the reality is that the API of the cloud itself, to me, no longer really matters. Applications are going to get written to an abstraction layer, and that abstraction layer needs to be able to speak to all these cloud services. The problem with Amazon and with customers that begin to adopt Amazon is that they've got a set of services that are compatible with every other cloud. It's basically storage and networking at its base layer. Storage, compute, networking at its base layer. Then they've got the other 120 services, things like database cache and queuing, that all speak their own language. And there's no way to build a compatibility layer with RDS and something that runs on Google, or something that runs on Azure, or something that runs on OpenStack. And so what you see is this challenge. I'm looking forward to your response, but you see this challenge of how do you actually begin to adopt multiple clouds when every cloud is fundamentally different. If you back up one layer and you say, all right, can I build or use a set of technology that can speak to all these clouds? And there are plenty of technologies that exist. There's platforms as service technologies. There are abstraction engines that allow you to do this. And there are things like Chef or Puppet or Ansible configuration management tools that allow you to speak to the base underlying object, whether that's compute, storage, or networking. You use those to build your abstraction engine. That becomes your API. And from that, you then build your application on top. That, to me, gives you something that actually allows you to enable true multi-cloud utilization. So from our perspective, that technology of choice is something like Cloud Foundry from a platform as a service perspective. You write your applications to talk to a platform as a service such as Cloud Foundry. Cloud Foundry is written from origin to speak to all the primitives across all the cloud providers. It can talk to VMware on-premise. It could talk to Google. It could talk to Amazon. It could talk to OpenStack. and you let that technology manage all of the application and all of the service dependencies. And from that, you have a platform that actually lets you run a true multi-cloud strategy. That's where I think we're headed. That's the reality I think we're at today. Amazon has had the lead. Everybody else is catching up, and now we're beginning to, in my opinion, see that transformation.